Last up with SMTP, I want to talk about a couple forms of abnormal stimulus and response. Now, SMTP is interesting because on its own, there isn't a lot that can be done to kind of dork with the protocol and do things that might cause results that could be bad. I mean, certainly you have misconfigured servers and you have things trying to connect to other things that aren't going to work, and you'll get appropriate response codes for all those things. So I'm not going to go over all that because it's pretty self-explanatory and the response code system is fairly robust. However, I do want to cover a couple ways SMTP as a service can be abused, mostly relating to a couple of security concerns. Now, with most security concerns with SMTP, it's really more about the content of the email. We certainly know phishing is probably the most common way that attackers get initial footholds onto the network is by sending emails with malicious links or malicious attachments and those things. But those are really, again, all about the content of the email and not an abuse of SMTP itself. Now, with that said, I wanted to talk about a couple things that do allow SMTP to be abused for maybe some more nefarious purposes. The first one of those is user enumeration. And in this case, we have System A, who's an attacker, and System B, who's a mail server. And for whatever reason, System A can communicate with this mail server, which is not going to be too odd, since most mail servers are set to listen, at least to certain types of communication over the internet. But in this case, let's just say System A just happens to be on the same network as System B. Now, one of the commands we looked at earlier somewhat briefly was the verify command, VRFY. And we talked about it just in the fact that a server would support it, but we didn't actually see it being used. Now, the interesting thing about the verify command is it can be used to verify the existence of a user or a user owning a mailbox on a server before actually sending the message. And there's plenty of reasons you might want to do this, but if you think about a system that allows you to verify if a user exists, well, that also is a system that basically allows an attacker to verify and map out user accounts on that system. And for an SMTP system, you could use that to derive usernames that might be mapped to network usernames, or you might be able to use it to derive mailboxes of sensitive people who you can send phishing or spear phishing attempts to, things of that nature. So not an entirely damning thing, but something that can occur with this verify command if this server is not configured to properly limit that or deny it altogether. So in this case, for our example, we have verify Chris sent to System B, and the system responds with 252 Chris. So it's responding back with the username, and code 252 generally means that it can't verify users, but will accept messages and attempt delivery. Some servers will respond to this when the account actually exists, even though it doesn't actually say it's verified. Of course, there's a few other things, codes that can be sent here as well. Let's say we try to verify the user John, but the user John doesn't exist. The server might respond with code 550, which means recipient address rejected because the mailbox is unavailable. That address doesn't exist. So this tells us quickly that John isn't a valid mail address here. So oftentimes, if you do see this going against a server, it's probably going to be some type of dictionary attack, a dictionary attack with some common names or common first initial last name combinations, or first name dot last name, and so on. And based upon the responses the server gives and how that server is configured, different responses will mean different things. But nonetheless, excessive use of the verify command generally indicates some type of user enumeration that's attempting to be done by someone, usually of a malicious nature. I want to talk about now just one more final abnormal stimulus and response for SMTP, and this is going to refer to open relays. Now, in this case, we have a mail server, and if you think about a mail server, one of its primary goals is to relay mail from one place to another. We saw that in our previous example, wherein we had an internal host sending mail to a remote host, and it had to our server had to relay that mail to another server, and that's perfectly normal. Mail servers are just that; they're supposed to relay information. But something that matters is the source of the information they're relaying, and I want you to consider this scenario. We have a mail server sitting out there that's exposed to the internet, and it needs to be, because it needs to be able to receive messages from other servers on the internet. But instead of only responding to requests from internal hosts on your network to relay mail, it will respond to messages from external or internet-facing hosts to relay email. Now, hopefully that sets off your spider senses, and that's something that doesn't seem ideal to you, and because that's really not a good scenario, right? If you have a public-facing mail server and it will accept mail from any other domain beyond your own and deliver it to any other domain, or at least try to forward it along, that's going to be troublesome for a couple of reasons, and I want to give you one of those right here. In this case, we have our system B here, which is our friendly mail server, and then we have system A, which is an attacker somewhere out there on the internet. Because system B is misconfigured and not configured to only relay messages for its own network or for its own domain, system A is going to send spam messages to system B. And these are not destined for system B itself, its own users. They're actually destined for other devices out there on the network. And this is called being an open relay, what we're doing right now with system B. It's openly accepting messages to relay to other places on the internet as if it were their own. So in this case, system B receives this spam and goes ahead and sends it out to all these different systems, all these different mail servers. I suppose they all say system C. We can assume those are systems C, D, and E, and so on. So it's going to deliver those messages. Now, there's benefits to this for the attacker, right? System C here, all these different mail servers out here, think the message is coming from system B. So if they're going to blacklist someone or block traffic, they're actually going to block system B. They're not going to know system A is out there. They're not going to block it. So this protects the attacker's infrastructure while abusing legitimate infrastructure of someone else. Now, this used to be a lot bigger problem quite a while ago, right? Open mail relays existed all over the place. Mail servers were configured to do this by default and so on. With the propagation of spam and that becoming an everyday thing, mail servers began to be configured not to allow this by default, so you don't see near as much of it. And quite honestly, if an open mail relay appears out on the internet, it gets found pretty quickly and gets abused quickly enough that it often gets blacklisted very, very soon. So if a mail server is an open relay, it might not exist as one for very long just because it will get abused by spammers quite heavily. So all this to say is if you're responsible for configuring and setting up a mail server, make sure it's not configured as an open mail relay. And if you're a packet analyst or a security analyst and you see your mail server accepting messages from other hosts and then forwarding them on to additional hosts that are not on your network, then you may have an open relay and you may need to look at this. So this is an abuse of the relay functionality of a mail server with an SMTP open relay. Definitely a normal function of SMTP, an abnormal function of how SMTP should work in the larger mail ecosystem, and something you definitely don't want to see from your own SMTP servers.